want to introduce our presenter for today, Bill Singleton. Bill leads our engagement with civil engineers and other transportation planners and stakeholders. He's been with Ecopia for over 8 years now, and he enjoys working with the civil end market, the transportation stakeholders, to better understand and improve the communities in which they operate. Prior to Ecopia, Bill worked for Cisco Systems in Canada. He has an MBA from Ivy School of Business with a focus on entrepreneurship and high growth companies. Hi, Bill. So thank you again for joining us today, and I'm excited to kick this off. Over to you now.
Thank you so much. Appreciate it, Harneet. And I want to thank everybody here today for taking some time to be with us. As Harneet mentioned, this is one of the first in a series of our presentations in the civil engineering industry. However, we have been working very closely with a number of civil engineers across the industry for the last 4 or 5 years now, building highly precise geometric data to help improve their business processes. Today, we're excited to talk to you about how we are helping these civil engineers leveraging AI-powered mapping data for safe, equitable, and complete streets. Our organization has been building this national map data, as I mentioned, for the last 10 years, and we're looking forward to all of your questions towards the end of the session. Now, in today's agenda, First, I'm going to summarize the data problem that our organization has been seeing in the industry. We'll then quickly touch on our vision for how we can help the industry and a number of the different players that we've typically worked with in the past to help digitize assets to help with their project, to help increase and expedite the speed of their projects. And then what I'd like to do towards the end of our presentation is focus on some of the data samples that we're already working with some of your peers. And so that'll lead us into some of the questions that each of you might have. So complete streets are designed to consider the needs of all users, such as people who are walking, bicycles, take transit, or drive, and varying ages of levels and abilities. But they also consider the other uses like sidewalk cafes, street furniture, street trees, utilities, stormwater management, and many other uses. While not every type of user may be accommodated on every street, the goal is to build a city with a well-functioning street network that supports and sustains our quality of life for all of its users. Complete streets ensure that social, economic, and environmental priorities are integrated into street planning and design to improve outcomes for communities. But before any of this can take place, we really do need to have a better understanding of what's going on in the world around us today. I'd like to highlight just one example of today's limitations before we get too far into our presentation, which is slowing our ability to plan and create the safe and complete streets, which I mentioned in the previous slide. Our ability to access necessary base map data for project planning and completion. Despite having national access to never before to the best aerial imagery, both from anywhere from the range of 1 to 6 inches, we really don't have the base map data that's required in order to support a lot of the project planning that needs to take place before we get started. Whether it's to plan for safety, to apply for federal funding, or to have a better understanding of how people are moving themselves through the communities which we're living. This highlights a lot of the problem. This is one of the earlier projects that we worked on going back a few years ago, working with tool design across a region on the East Coast. And in this particular example, this is showing the pedestrian map data, so identifying all of the sidewalks and crosswalks that the community was using to plan for future projects and to apply for federal funding. And so you can see in this example, OSM data has been mixed with public sources that have been developed by interns. And you end up having a hodgepodge of a number of base map assets that were created from thousands of different contributors, from hundreds of different data sources. And so really there's no standardization and no completeness to being able to understand what's going on in the community in which they're planning for. And that's where Ecopia was able to significantly help with this process. And that's where we want to leverage the power of AI to have a much thorough understanding of the assets that are in the communities that we're working with today, so that we can help understand how we can affect change and improve the future outcomes for safe and complete streets. And so you'll see in this particular example, we have a 10 times increase in the amount of map features that we were able to identify for the Baltimore region. But we can actually go one step further. And remember, this is just two features, sidewalks and crosswalks, of a large portfolio of features, which I'll show you as we go through today's presentation. But by having a better understanding of all these assets, we can also attribute each of these segments or each of the geometry, individual pieces of geometry in this area, to add additional information, such as width or passable width for all of these pedestrian features. And even just having this understanding, it makes it a lot easier to visually understand where communities need to be investing to make their communities more equitable and safe for their pedestrian road users. In this particular example, we are highlighting any areas in green that have passable width of a sidewalk of greater than 6 feet. Meanwhile, everything in yellow and orange is identifying passable width in the 4 to 6 foot range. And anything in red is below 4 feet in passable width, which doesn't even meet previous standards of ADA, of American with Disabilities Act compliance. And so this community can have a better understanding of where investments need to be made in the future to make their city a safer place to work and live. And also, it can help with federal funding initiatives. And so in this particular region, several counties are using this data to apply for Safe Streets for All funding through a number of the different programs that are available through the IIJA Act at the federal level. So let's take one step back. I wanted to quickly show you some of the ways that we've helped out in years past, and we'll have further data examples as we move forward. But what I wanted to quickly touch on is what our vision is of what we are trying to do as an organization. Our organization is trying to digitize the physical world, but really, what does that mean for the civil engineers that we're working with? It really means that we're trying to completely eliminate manual digitization to help improve the speed and flow at which you're working with projects, and also improve your ability to estimate and understand how much work is involved in order to get to the future desired state of your community. When we initially got our start, our organization was focusing on basic features for federal governments to understand some map assets that were typically manually digitized, like road networks and building footprints. But what we recognized is if we could use much higher sources of aerial data, so that 1 to 6 inch aerial data that we were talking about in the past, there is a much broader portfolio of about 60 assets that we can start to identify to help communities have a better handle on the assets in which they're using and responsible for managing. And so that's where we've expanded to working in a number of different places, specifically what we'll talk about today in the transportation right of way. Our organization over the last 10 years has been building map data across the globe. So working in over 100 countries and building data sets on an annual basis across the US. And the reason why I bring up this slide is that there's a lot of organizations that do have tools out there that that claim to be able to identify certain kinds of items from machine learning or AI widgets. And these are great for standard users, but really, at the end of the day, you need to have that high degree of accuracy to ensure that your organization has the confidence level to use these in your project scopes moving forward. We have a lot of experience working in a number of different fields, whether that's insurance, to the federal governments, to the civil engineering. And that's why we have built a system that has such a high degree of accuracy, which I'll discuss in a few slides here when we get into our process workflow. This is just some of the peers that we're working with in the industry. We have a lot of experience working with Alta and Fair and Priors across California and the West Coast, identifying a number of transportation assets for safety studies, and then also understanding permitting and having a better understanding of what work would be required in order to create complete and safe streets. We also have worked with organizations like CHC, which I'll show you some examples from each of these organizations a little bit later on the presentation, to do permitting and to have a better understanding of paint striping and what kind of assets are on the actual street, on the street level, so that you have a better understanding of how we can start construction projects. So this is a general summary of some of the data sets that we will show a little bit later on in the presentation. Our main objective is to highlight a number of the portfolio of 60 assets, whether it's bike lanes, curbs, to everything from sidewalks and road markings, like I mentioned, even identifying things like medians when public sector sources really aren't available or they have fallen out of date. And what we're supporting is a number of different applications in the civil engineering field, whether that's active and multimodal transportation planning, helping with pedestrian right-of-way analysis, and even supporting a number of different Vision Zero initiatives, like some of the work that we did across San Francisco. So we really want to be able to collect all of these assets so that communities can identify areas where there isn't equitable transportation networks, so that we can help improve that moving on into the future. So a little bit about our process. At the end of the day, anybody who's saying that they're using AI automation and throwing that at remote sensing data in order to extract highly precise features, those examples should be a little bit of a red flag for you. We've been doing this for almost 10 years now, and even we have humans in the loop in order to create an iterative process where we're constantly improving our ability to extract highly precise information at scale. We actually do this for selfish reasons, because every time we take on a project, we want to identify and increase the training sample that we're working with in order to improve our capabilities of extracting those kind of features from that specific kind of terrain across the globe. And that's really what's allowed us to continue to build our system, so that we can have the highest degree of faith within our content, so that your teams can get right to work. At the end of the day, the one thing that I do want to stress is that our organization is a content provider. We are providing base map content for the civil engineering industry, and we do not want to change any of the applications that you're currently working with today. All of our data can be used by AutoCAD, City Engine, all of your Esri products. If you're QGIS users, all of that data is in shapefile, GeoJSON, or geodatabase format, so that we are not changing any of the processes that you're used to working with today. And so that we want to be able to provide data so that your teams can get right to work, helping the communities in which we're working with. Our process, one of the advantages of our process is that we're able to use a number of different source images in order to extract the types of features that our clients are looking for. So whether you need satellite imagery to have the most recent vintage, or to be able to keep track of certain communities on a much more frequent basis, to working with aerial imagery where we can use 1 to 6 inch imagery sets on an annual basis to really have the highest degree of absolute accuracy, and to be able to identify a much smaller assets, which we'll cover in a few minutes here. And one of the things that we're most excited about is now also incorporating street view imagery into that process to understand more about more aspects like pavement quality and other features that we're already identifying as an organization. Our Ecopia AI is working with all of the major providers. We use all of the major satellite providers for most of our global work, but we also have relationships with Nearmap and Hexagon in order to ensure that we can have national coverage using the best aerial imagery available. And what does that allow us to do? So essentially, some of the limitations that we've seen in the past is trying to balance using automated software or manual digitization. And so when you're working with manual digitization, you can always ensure that your GIS professionals are creating the highest degree of quality within their product. Typically, we see human digitization at 95% accuracy, because you're always going to have some limitations with working with remote sensing data. But but really that's not a scalable approach to be able to identify all of these kinds of assets across a national scope on a frequent annual basis. And that's where being able to combine both of these methods provides us the capability to create national base map data for all of the transportation right-of-way requirements at the highest degree of accuracy. And that's really, as an organization, what our objectives are, is we're trying to take advantage of the best of both worlds in order to provide base map data that can help public sector, civil engineers, and other verticals get right to work and have a much better understanding of what is going on in the communities that they're working with. So I'm going to quickly touch on a few use cases with some of the organizations we've worked with in the past. Towards the end of the presentation, I'm also going to jump into some of the data that we have online, which I'd be happy to forward to anybody who's on today's call so that you can have a better understanding of the different kinds of map features that are being extracted across the country. But one of the first examples I'd like to talk about is some of the work that we are engaged with, working with municipal MPOs across the country and also with state DOTs. And so one of the first earliest projects that we undertook was working with SEMCOG, and I'll show you this data set in a few minutes, where we were able to extract over 24,000 miles of sidewalk and 160,000 crosswalk polygons in a very short period of time versus having to go out and manually digitize all of those assets. We've actually also been asked by SEMCOG to continue that work and to significantly increase the portfolio of features that we're asked to extract so that it can help organizations in the civil engineering industry help with their project planning processes. This is one example I'd like to show from some of the work that is being able to support applications like City Engine. So in this particular example, our organization provided laneway data for the San Bernardino area. And this is by using that raw data, which you can see in this exhibit here, the organization was able to load all of the information as to what is the width and all of the separate assets that are currently in the public right of way, and how can we adapt those in order to create a more inclusive, complete street for the community. And so by having this data created and understanding all of the different assets, whether it's the road width, the presence of medians, presence of parking, and the number of different lane configurations, you're able to load that into other applications, whether they be AutoCAD or the City Engine, as I mentioned, and be able to start to adapt and play with these with this kind of data. But instead of having to go out, collect all of that information, source aerial imagery, and then have to use manual resources in order to digitize that work before you can get started. And that's really where we want to be able to help your organizations, is give you a clear understanding of what's going on in the environment today, so that your organizations can get right to work. The next case study, which I'll show, and I'll show this data set in a few minutes here, is our work with the County of San Bernardino. So in this for the county, we were extracting a list of about 15 features here across the entire county, which is one of the biggest counties in the United States, at about 20,000 square miles. So our organization is building data sets across this area. And Farron Pierce had mentioned that we were able to create a 45 time increase we were able to increase the amount of information by 45 times in the multimodal and active transportation planning. The next case study that I'd like to present is some of the work that we're doing in permitting. So this is specifically for construction and understanding before any development takes place, is understanding what is going on in the public right-of-way today, particularly with public works requirements and paint striping. And so we were able to use our AI to extract all of the the paint identification across Columbus and San Jose. And this is something that we are going to be building out into all of the major urban centers, starting with the West Coast as we approach the end of this year. The last case study was a base map that was created in support of Contra Costa County and Caltrans grants. And that was having an understanding of all of the different laneway configurations across the entire region. And so this is something that we have the opportunity to work with either the public sector, who can pass this information along to our civil engineering partners, or work directly with the civil engineering industry to provide them those important data sets in order to improve upon their workflow, helping with that estimation process, and helping to submit bids in a much more expedient fashion. The last case study I'd like to talk about today, and this is something that is available for organizations that are working directly with the Chicago Metropolitan Agency for Planning, is our organization is using is a multi-year agreement where we are taking the newest aerial imagery every single year and identifying a number of 26 distinct layers across every MPO in the state. And this information is helping to provide for long-term planning purposes, for ADA compliance and Vision Zero requirements, and then also to help with any construction projects that are going on in the area. And similar to what we presented at the beginning of the presentation, in this particular example, we are identifying all of the pedestrian features, which we will be doing across every city as we go through Q1 of next year, and identifying their passable width so that organizations have a better understanding of what's going on in the cities in which they're working. And so we can send data samples for some of the cities that have already been created, so that you can see how this passable width data can help support some of the applications or some of the projects that your teams might be working with. So there's some of the 26 features that we're working with not only focus on things that are in the pedestrian right of way, we also are creating land cover data to support a number of applications across these cities. One of the interesting use cases that our team is running into, specifically in areas in the Sun Belt, is understanding where there is overlap between tree canopy and the pedestrian infrastructure. Because what they're finding is that in a lot of these cities, if there isn't any shade that's present, then nobody is using those city assets. And so having a better understanding of how this tree canopy can help improve the usage of some of the city assets that are already in place. And so this is just a quick example of the different kinds of features that have been extracted for the Illinois Department of Transportation and Chicago's agency for mapping. So as we come up to 2:30, what I wanted to do is to show you 3 examples of some of these data sets, and then we can get into any questions that people may have, and we can use some of the data from some of our previous projects, which is being leveraged by some of your peers. So the first data set that I'd like to show today is that SEMCOG project that we were working on. In this particular example, they wanted to have an understanding. This was one of our first projects going back 5 years ago, as I mentioned, to identify all of the marked and unmarked crosswalks and all of the sidewalk centerline infrastructure across the entire region. And there was multiple reasons why they were looking for this information. The first was to have a better understanding of doing an isochrone analysis of what is the walking time between some of the commercial parking, the medium and light commercial, to some of the neighborhoods in the region, so that having a better understanding of what kind of pedestrian infrastructure is supporting people's travel times across the region. But the other piece was to mix that with zoning data to have an understanding of how much of their population was within 100 feet of the nearest sidewalk. And so even before you get into a statistical analysis, you can see in a lot of these cases some of the neighborhoods that have gone under invested in. And so what they were able to identify was that 78% of the population was within 100 feet of the nearest sidewalk. But the unfortunate reality of that analysis was the 22% that did not have access was typically the most vulnerable and required the use of mass transit. And so they were the ones that were having to walk on streets in most cases in order to reach their nearest point of entry to mass transit sites. And so that was something that using this information, they were able to start planning for a future where they could fill in a lot of these gaps, not only using municipal funding, but by trying to identify these sites for federal funding opportunities. The next sample that I wanted to show was our work across San Bernardino. So this was the San Bernardino County study that we worked on with Fair and Pierce. And everything can be a little bit intimidating when you have all of the different features turned on. But as I showed you in the previous example, you can turn things on one at a time, so you have an understanding of all of your sidewalk center lines and each one of these segments has width attribution as well. Also, I do want to make one quick point. This is an online viewer, which we can send out, but all of this data is a vectorized format and can be provided in geodatabase, AutoCAD, GeoJSON, whatever format works best for your individual requirements. But we can start to take a look at everything within the public right of way and support applications like the one I showed you previously, where the City Engine application can look at different kinds of ways that you can use the width available in order to change these transportation models to make safer and more equitable complete streets. And so we can take a look at understanding, we can include an understanding of raised and painted medians across the entire region. We can also add things like planting strips. So understanding if there's any room with towards or beside the road networks for us to also include additional transportation features. Looking at the configuration of each of the intersections. So whether that's having an understanding of different kinds of turning features, right turn lanes and left turn lanes, which you can see highlighted here. And then, as I mentioned, looking at things like tree canopy and tree canopy intersection with some of the sidewalk features, so that you can have a better understanding of how some of the pedestrian infrastructure is shaded, and identifying individual street trees, which can also impact obstructions that are changing the way that your organization can do its analysis to have a better understanding of how much room is available and what would be the requirements in order to adapt these individual road segments depending on the customer's requirements. Another item, one last item that I'll show you before I go to one of the final examples is having a better understanding of a national shoulder network. And so in each of our analysis, we're identifying all of the shoulders within the community and the width of those pieces as well, along with the different kinds of marked bike lanes that exist. Every organization is a little bit different on how they want data represented. In this particular example, we were segmenting in between intersections. If this is something that you'd like to have as a connected infrastructure or as a connected polyline, that's something that our organization can also help with. And that's why we appreciate having the opportunity to work with our clients to have a better understanding of how they want data represented, because every application and every requirement is slightly different. And we do have that adaptability in order to show how certain features should be visually represented when we complete our analysis. The last piece that I'd like to show the attendees of today is some of the work that we're able to identify, some of the assets that we're able to identify now that we're also combining the use of Street View. And so when I turn everything on here, you can see a lot of the polygonal information, which I showed you in some of the previous examples, along with the polyline information. But once we start to work with street view imagery and oblique imagery to support our analysis, we can start to identify features that really don't have a very large profile when you're just using ortho imagery. And so that's when we start to be able to identify things like automatically identify things like traffic signs and traffic lights, identify things like power poles. So having a better understanding of the obstructions that are on that are at street level. So to help improve the analysis or the change analysis that your teams might be looking at, to identifying things like manholes and other point features like storm drains when you may have construction concerns. And so this is another thing that I can also this is another example that I can also provide so that you can have a better understanding of what our system is able to identify at scale.
Okay, I think we're right on time, 4 minutes short. So thank you again for your concise presentation, all the real world examples. And I really want to thank all the participants who took the time out of their schedule to join us today.